The topic is Taiji Mechanics Outline. J. Gu, Professor of Taiji Culture Institute, Handan University. Invited to do seminar by Physical Education Institute, Suzhou University. Chapter 9. Mechanical Analysis of Taiji under Horizontal Force using Human Plane Rigid Model. Human model comprises mass center, contact hand, feet position, rod connecting between joints. External force includes horizontal force, normal and friction force beneath feet. Model has body mass, body moment of inertia, body velocity, body angular velocity, mass of contact hand, velocity of contact hands, etc. Two feet critical condition of no root loss. 2 feet critical condition of no slip. Chapter 9. Mechanical Analysis of Taiji under Horizontal Force using Human Plane Rigid Model. Continued 1. Newton's second law in horizontal direction. External horizontal force equal to the product of mass and acceleration. External forces are balanced in vertical direction. Gravity equal to normal force. Newton's rotation law. External torque equal to the product of moment of inertia and angular velocity. Fx is the force at contact hand. W is the gravity. Nq and H are the normal forces. Fqx, Fhx are the friction forces. M0A0x and IZ gamma are the impulse forces induced from the body momentum and body angular momentum. MJAJX is the impulse force induced from the contact hand momentum. Solution. Normal force equations for the 2 feet. The tangent of angular line of force equation. Chapter 9. Mechanical Analysis of Taiji under Horizontal Force using Human Plane Rigid Model. Continued 2. Input for the bow stance. Body acceleration, body angular acceleration, contact hand acceleration, feet position, horizontal force input series. Calculate the critical force for 3 cases. The critical force when there is only supporting floor is Fx equals to 294 Newton. The critical force when there is supporting floor and the body momentum is Fx equals to 544 Newton. The critical force when there is additional explosive force source is Fx equals to 744 Newton. Chapter 9. Mechanical analysis of Taiji under horizontal force using human plane rigid model. Continued 3. Similar calculation can be carried on for other stances, such as sit stance, virtue stance. Calculation results reveal that bow stance is good for push and sit stance is good for pull. Two competitors doing push hand. Bow stance push win over sit stance push. This proves throw like an arrow. Sit stance pull win over bow stance pull. This proves induced empty. The analysis shows that when the opponent's momentum is exploited and the additional my momentum is transferred to the opponent can be thrown 4.3 meters away. This proves 4 ounce win 1,000. Chapter 10. Mechanical analysis of Taiji under vector force using human plane rigid model. It is still plane model. Fx, Fy, Fz is the vector contact force with 3 components. M0 V0x, M0 V0y, M0 V0z, and Iy omega y, Iz omega z are the 3-dimension body momentum and angular momentum. Mj Vjx, Mj Vjy, Mj Vjz is the 3-dimension contact hand momentum. Chapter 10. Mechanical analysis of Taiji under vector force using human plane rigid model. Continued 1. Newton's second law for horizontal x direction. External force in x direction equal to the product of mass and x direction acceleration. Newton's second law for vertical y direction. External force in y direction equal to the product of mass and y direction acceleration. Newton's second law for lateral z direction. External force in z direction equal to the product of mass and z direction acceleration. Newton's rotation law around y-axis. External y-axis torque equals to the product of y-axis moment of inertia and y-axis angular momentum. Newton's rotation law around z-axis. External z-axis torque equal to the product of z-axis moment of inertia and z-axis angular momentum. Chapter 10. Mechanical analysis of Taiji under vector force using human plane rigid model. Continued 2. Solution. Normal force equations for both feet. Friction force equations for both feet. Tangents of angular line of force for both feet. Chapter 10. Mechanical analysis of Taiji under vector force using human plane rigid model. Continued 3. The input of a sit-stance pole. Feet position, contact hand position, body acceleration, body angular acceleration, contact hand acceleration, external force Fx import series. External force Fy import is proportional to Fx. External force Fz import is proportional to Fx. Calculate the critical force of sit-stance for 3 cases. The force capability of support force source only is Fx to Fy to Fz equal negative 226 to negative 68 to 113 Newton. The force capability of support force and the body momentum force sources is Fx to Fy to Fz equal negative 469 to negative 141 to 235 Newton. The force capability of adding explosive force source is Fx to Fy to Fz equal negative 569 to negative 171 to 285 Newton. Chapter 10. Mechanical analysis of Taiji under vector force using human plane rigid model. Continued 4. The input of a single foot stance kick. Body acceleration, body angular acceleration, contact hand acceleration, external force Fx input series, external force Fy input according to a formula. Calculate the critical force for 4 cases. For transfer force source, the capable attacking force is 2120 Newton. For adding body linear motion, the capable attacking force is 2679 Newton. For adding crouch flip, the capable attacking force is 3231 Newton. For adding hand relative motion, the capable attacking force is 3452 Newton. Chapter 11. Mechanical analysis of Taiji under vector force using human 3D rigid model. (3D model). There are lateral distance between the 2 feet. There is a lateral distance for the contact hand. There are lateral friction forces. Fx, Fy, Fz is the vector contact hand force. M0A0x, M0A0y, M0A0z, and Ix alpha x, Iy alpha y, Iz alpha z are the impulse forces from the body momentum and the body angular momentum. Mj Ajx, Mj Ajy, Mj Ajz is the impulse forces from the contact hand momentum. Chapter 11. Mechanical analysis of Taiji under vector force using human 3D rigid model. Continued 1. Newton's second law for x, y, z directions. X direction external force equal to the mass times x direction acceleration. Y direction external force equal to mass times y direction acceleration. Z direction external force equal to mass times z direction acceleration. Newton's rotation law around xyz axis. X-axis external torque equals to x-axis moment of inertia times x-axis angular acceleration. Y-axis external torque equals to y-axis moment of inertia times y-axis angular acceleration. Z-axis external torque equal to z-axis moment of inertia times z-axis angular acceleration. Chapter 11. Mechanical analysis of Taiji under vector force using human 3D rigid model. Continued 2. Solution. Normal forces for both feet. Friction forces for both feet. Tangents of angular line of force for both feet. The formulas for 3D model is more complicated than the formulas for plane model. The special case from 3D model is for plane model. Chapter 11. Mechanical analysis of Taiji under vector force using human 3D rigid model. Continued 3. The import of bow stance slant saw. Feet position. Contact hand position, body acceleration, body angular acceleration, contact hand acceleration, x external force Fx input series. Fy input series are proportional to Fx. Fz input series are proportional to Fx. Calculate the critical force of bow stance for 3 cases. The force capability of support force source only is Fx to Fy to Fz equals to 236 to 71 to 94 Newton. The force capability of support force and body momentum force sources is Fx to Fy to Fz equals to 461 to 138 to 184 Newton. The force capability of adding explosive force source is Fx to Fy to Fz equals to 561 to 168 to 224 Newton. Chapter 11. Mechanical analysis of Taiji under vector force using human 3D rigid model. Continued 4. Sit stance pull, wind over bow stance bounce. Pros 4-ounce deflect 1000. Chapter 12. Excel spreadsheet inverse calculation. The formulas are complicated. There is no forward solution. There are 4 critical conditions: front foot, root loss; rear foot, root loss; front foot, slip; rear foot, slip. Have to find the solutions for one of the critical conditions by one set of equations. Excel spreadsheet inverse calculation is an effective way. Import external force series. Put them into the equations for a test calculation. Check to see if one of the 4 critical conditions is met. List the result in a table to show the trend. Look for the first critical condition and the corresponding external force. In the table, the first critical condition is when the last column gets to 0.5. The corresponding critical force in the first column is negative 150.34 Newton.